Okay, so here I am. We're using YouTube's copyright-free audio library, and what's going on is I've got my subwoofer down here in my entertainment system that's giving me some problems, particularly crackling under high bass, high volume. And of course it's not doing it now, but when it does it, what happens is the bass level decreases dramatically, along with some crackling and some popping, and the cone actually looks like it develops a DC bias where it wants to be in or out slightly, with maybe a few volts of DC pushing the cone in or out as this happens. Anyhow, so I'm going to pull the thing apart and see what we find inside. Okay, so the first thing I'm going to do is just take a look at the surround on this one. I believe this one actually is a rubber surround, and it feels really good. It doesn't feel fatigued. I don't feel any cracks in it. Everything looks good there. So it's still sitting here in the entertainment center where I use it. So I'm going to pull it out and take a look at it. We'll pull the back off of it, and I'll try to see if I can find a service manual on it and take a look at the schematic and see what they're doing as well. All right, so this one is a model SA-WM500. And so I'm logged into HiFiEngine.com, and I did find a service manual for an SA-WM500. So let's go ahead and download it. And we'll get over here and tell it to save. Save, and we're downloading, and it's done. All right, so here is the Sony service manual. Let's get over to the schematic diagram, and I'm primarily interested in what are they doing for an audio output. STK404-140. And so what I'm primarily looking for is some low value capacitors attached to the audio output IC. And then I wanted to take a look at the power supply circuitry in here, the plus and minus 12 volt regulators, as well as the overload detect. I've never had a problem with it overloading. And then take a look and see what they're doing in the preamp circuitry. A lot of those are capacitively coupled as well. And so we'll just pull this thing apart and take a look at all the little capacitors in here. After all, this thing is probably, I'm trying to remember when I purchased it, probably in the early 2000s, I would say. And it's actually served pretty well. I've never had a problem with it. It's always sounded good, but we'll go ahead and pull it apart and see what it looks like inside here in just a moment. So I've got the schematic all printed out here, and I went ahead and I just circled all the electrolytic capacitors I'm going to be checking in here. And so I've got the subwoofer board out of the unit. So here's the STK power pack along with its associated capacitors. And then down here, kind of hard to see through all the shield here and whatnot. This is the power supply and preamp board, and the level adjust board here has got some electrolytics on there. So I'm going to go ahead and pull the cover off. We'll pull the STK chip off the heatsink and remove these screws back here so we can get to the bottom of the board. And we'll go ahead and ESR those capacitors and see if I can find anything. Worst case scenario, it's a possibility the STK output chip may have a failing output transistor in it. And if that's the case, I'll just have to go ahead and replace the STK pack. They are known for failing as they expand and contract over time as things heat up. There's the bottom of the preamp power supply board. So we'll get into that, and I'll bring you along for the ride, and we'll do some ESR checks on these parts and see what happens. One thing right off the top, I don't know if you can make it out on the camera or not, I see a ring around this connector, which means there could be an intermittent solder connection based on vibration. That's one of the line input connectors here. And I'll take a closer look. It looks like it is the line in, so that might be a very distinct possibility. So I've got the camera zoomed in on it, so I don't know if you can see it on the camera or not, but even as I just move this around, I can actually see the center conductor moving in it. Just a poor solder job. You really thought that they would have given this just a little bit more solder from the factory. Yeah, I can definitely see movement there. Wonder if I can get on the back side of that and press it all. It's pretty typical in electronics when they do a poor solder job of any kind of a fixed device that has a large mass, even a large thermal mass. As it heats up and cools down, typically these things want to kind of move around. And I'll typically see that when there's like a large power pack IC or a connector like that. I'll start to see some bad solder connections even on these connections where the connectors plug on right here. There's a possibility that that one may have a bad connection on it. It's got a little ring around it as well. So I might just be looking at a simple matter of a poor solder connection on this guy. Anyhow, let's tear it down and see what we come up with. Okay, so I'm just going to start and remove the screws from the STK power pack. See how that's mounted to the heatsink? Oh, very loose. They used a lot of heatsink compound, but they certainly didn't get much where it counts. Very thin heatsink compound, it all squished out. Well, we'll put some more on there before we put it back together at least. So I'm just going to start and wipe off the excess heatsink compound off this chip so I don't get it all over the place. Take a quick look at those connections. They actually look pretty good. There's one that's kind of suspect, but we'll pass on that. So I've got 1, 2, 3, 4, 5, 6, 7 capacitors on this board. I've got my ESR meter here ready to go. Make sure it's on 0. That one seems to be okay. 47 microfarad at 100 volts. That one reads about 1 ohm. That was a 10 at 100, so I'd say that's perfectly acceptable. Now we got these two right here. About 1.5 ohms. And about 1 ohm. They got Celastic on it, so it's kind of hard to see. No numbers on the bottom of the board. Maybe we can figure out what pins they go to on the board here. 1, 2, 3, 4, 5, and 6. 10 microfarad at 100, so what do we get? About 1.5 ohms on that one? Yeah, that's okay for a 10 microfarad capacitor. And the next one goes to 7, 8, 9, and 10. That must be 100 mic at 25 volts. That was about 1 ohm, so that's perfectly acceptable. So I'm just going to take and mark off the ones that I've checked already. 10 at 100 goes to, looks like pin 1 and 2. So now I've got a big one right here. That's the 100 at 100. That one's perfectly good. There's a 10 at 50 over here. Let's check that guy. 1.5 ohms. That's a 10 at 50. So we have to find a 220 at 25 and a 2.2 at 50. So pin 7. Interesting. That one checks good. 220 at 25. Having a problem finding this one right here. C705, 2.2 at 50 volts. Goes through a 1K resistor to pin 7. Now in the unit it appears to be a 10 microfarad capacitor. It's this one right here. I know I checked that one. It's almost 2 ohms. So they may have done a change. But all those on the amplifier board seem to be okay. And I suspect the chip is actually okay as well. So I'm going to, since I use so much extra heatsink compound, I'm going to re-smear the heatsink compound around and mount this back to the heatsink. So we'll go ahead and use their excess heatsink compound. That should be good. Got a nice coat of compound on there and a nice coat on the board as well. So I'm using this rigid impact driver. Works pretty good, and it doesn't strip out the screws, unless you go too far, of course. So next we'll pull this board off and we'll check all the caps on it as well. So we'll go ahead and pull out the screws from the speaker terminals. Get the board completely off the chassis. Alright, the board's completely free. Go ahead and unplug all the connectors on it. Alright, so it's completely free from the chassis. Got a zip tie on there. Alright, so the board's free. We'll go ahead and do the Esr checks on all these little capacitors hiding on the board here and see what they come up like. So we'll start with the two main filter capacitors. I expect them to be 0 ohms. So let me check my calibration on the meter here. We'll check those guys. 0 ohms. I'd expect that because those are 71 volt 10,000 microfarad capacitors. Next we'll check the 220 at 25s, the filter capacitors for the plus and minus 12 volt power supplies. Close to 0, I'd expect that. If I saw more than about an ohm, I'd be concerned. They're probably a 1/4 ohm each, so those are okay. Yeah, that one's a little over 2 ohms. A 10 microfarad at 50 volt. For 10 microfarad capacitors, I would accept that as being a good measurement. 10 at 35, these two little caps right here. We'll check those next. Yeah, about 5 ohms on that guy. And 4 ohms on that one. Let's see where those are in the circuit. So that's C810 and C809. That's these two. Those are the output filter capacitors for the plus and minus 12 volt regulators. These are the two 220 microfarad caps we just checked. Those are okay. And the two main 10,000 at 71s, those checked okay. So I'm pretty happy with that. I think being 4 or 5 ohms on these isn't going to be too terribly critical. They're just output filtering, output smoothing. So we'll go down the line. Looks like C532 and C403 are the two next ones we'll check. That one certainly checks good. So 330 at 10 volts. Next one will be a 220 at 10. Half an ohm. That's perfectly acceptable. So what did I say? C532 and C403. C532, C403. Now we'll check C401 and C531. C401 appears to be a 2.2 at 50, and 531 is a 22 at 25. 10 ohms on the 2.2, which is acceptable. And 1 ohm on the 22, which is acceptable. So that was 531 and 401. Ah, there it is. I didn't circle it. So we'll check C402. That one's good. C402 is a 330 at 35. That's perfectly good. Now it looks like we got 2 more to check. C501 and C522. 4 ohms on C501. Wait, excuse me. That was C522. And about 3.5 ohms on 401. So that's all the capacitors on the main power supply preamp board. Next, we'll remove the input level board. This little guy right here. We'll check the caps on it. Now, according to the schematic, there's 4 capacitors on this board that we're going to check. These 4. 4.7, 22, 22, and another 4.7. And I definitely see 4 caps on that board. 2 ohms. I'm good with that. 1 ohm, 1 ohm, and 2 ohms. I'm okay with that. With being 4.7s and 22 microfarad caps. I'm perfectly okay with those. So we've just checked all the capacitors on the main board, the level input board, the power supply, and the power amplifier board. I'm perfectly okay with all those. My biggest concern is this connection with the loose connection right here, which could be causing all of my symptoms on this subwoofer. So I've got my 862D Plus set up for 815 degrees. You may have seen me make a video on converting it from Celsius to Fahrenheit. So I'm just going to go ahead and touch up these connections. That looks good. Next, I'm going to go over and just solder the connections to this one connector to the power amp board.
There are over 32 million Americans with Irish ancestry, Irish DNA. Ireland's entire population is only 3.2 million. So we've got a whole lot more partiers here in the U.S. Chico's Classic Hits 96.7 KZAP.
That looks good. We'll take care of these other connectors on the edge of the board. Let me move the camera for you. Take care of these connections over here. Especially that one right there looked bad. Touch up the speaker terminals. I'll hit these connections from the preamp board. Much better. Those all look very good now. I should have done this one before I put the board back on, but I'm just going to touch up the connections on the STK power pack. That's good. Now we'll touch up the connections on the connector from the amplifier board. Hopefully you can see this on the camera. Those all look very good now. Now we'll go ahead and reassemble the unit and we'll give it a test and see what we can come up with. Just going to touch up the emitter resistors real quick. So just in case anyone's asking, the solder I'm using is Esr, and it is the 6040 with a 31 thousandths diameter solder. Has the flux in it, works very well. And for surface mount units, I do have a roll of 6337, 15 thousandths diameter, very small diameter solder for very critical surface mount work. When I have to use flux, it's the Amtech flux. You can purchase this on Amazon. It's a very good flux. It has a very high boiling point. So as you're soldering, it does not evaporate. And once again, the soldering station, hot air rework station I use is the basically unbranded brand 862D Plus. And I did a video on converting this unit from Celsius display to Fahrenheit. So it does display in Fahrenheit display instead of Celsius now. Good for those of us who are in America. And it does come with multiple tips. I've ordered a couple extra ones. These are the interchangeable tips for the hot air blower, different diameters for different kind of devices. The one I typically use is this very small one. It's probably 3/16 inch diameter. Does a very good job on pinpointing just the individual item you want to heat up without heating up a lot of the surrounding areas. So in the schematic, they left off this other 0.22 ohm resistor. They show the one right here, but they didn't draw this one in the schematic. So out of pins 12 and 13, they go through the 0.22 ohm emitter resistors to the output, which is output on pin 3. So I just thought it was interesting they left this out of the diagram when it is clearly in the circuit. So real quick, here is the Sanyo application data sheet on these chips. And they show everything down from a 404-050 rated at 35 watts at 0.4 harmonic distortion, 45 watts at 10% harmonic distortion, all the way up to the one this subwoofer uses, the 404-140S, rated at 120 watts continuous RMS power at 0.4 total harmonic distortion, or 180 watts at 10% harmonic distortion. And so here's the pinouts for it, and it looks like it's just a complementary Darlington output pair, outputting on pin 12 and 13. And so you can see here, they've shown the extra 0.22 ohm emitter resistor on 12 and 13 that Sony neglected to put in their service manual. So here's the pinout on that, if that might be useful to you. So you can see the input is on pin 3. And then it looks like they have a bootstrap input possibly on pin 6 with a feedback going back to pin 4. And once again, the output on 12 and 13. Your plus VCC feeds to pin 11. Your negative VCC feeds to pin 10. So hopefully if you're having a problem with this unit, this will help you troubleshoot it. Alright, so I'm going to go ahead and get the unit put all back together right now. And we will give it a try and see if we've gained anything. And if not, we'll have to replace that 404-140S audio amplifier IC. Okay, well, it's been a little more than a week since I tore the subwoofer apart and did some repairs to it. So I've got the same song ready to go here on the YouTube audio library. I'm just going to go ahead and hit play here. Anyhow, the thing's been working absolutely flawless since I did the repair. I don't believe, well, of course, you saw me ESR all the capacitors in there. I don't believe there were actually any defective capacitors. I do believe, however, that it was that input jack solder connection that was causing the entire problem. Once again, no animals were harmed during the making of this video. Anyhow, it's working perfect. It's been working fine for a little over a week right now. No cutouts. One thing I had noticed previously is that the little power indicator down here that is normally green when it has audio and it turns red when there's no audio, and this would contribute to that bad solder connection, is occasionally we'd be watching it at just a moderate volume and the subwoofer would just go into the sleep mode, and obviously if it doesn't sense any audio input, it's going to go into the sleep mode. Anyhow, I hope you enjoyed the video, the teardown of the Sony subwoofer. If this video has helped you, please consider making a donation on my YouTube homepage or at paypal.me/NorCal715. Everybody have a great day. Thanks for watching. Remember, you can follow me on Twitter at NorCal715. Bye-bye.